So in evaluating this definite interval, according to the second fundamental theorem of calculus, I can dive in and simply anti-differentiate that piece. What is that going to be this? That's going to give you this. And so if you interpret that as underneath the curve is 2 root 2, I think. You know, maybe I'm dramatically wrong. Technically speaking, from here to here, I use the second fundamental theorem of calculus, which says as long as this function is continuous over the closed interval from 1 to 3, we're in business. Unfortunately, that function in Lagrange position is not continuous over the interval from A to B. And so here's an example where I have an improper integral, and I've committed a grave mathematical sin. So let me go ahead and repent. In repenting, here's my way out of it. This is one of two types of improper integrals. The one type for which the function in the integrand position is not continuous over the interval from A to B. In such a case, if that discontinuity is at one of the endpoints, I'll rewrite this as a limit. As, I don't know, look at my pretty picture. Notice how if you interpret that definite integral as the area underneath the curve, it's an unbounded region. Now, just because this region is unbounded doesn't necessarily mean its area is infinity. It could be finite area. I don't know. But here's how I determine that. I don't integrate from 1 to 3. I integrate from somewhere close to 1, like, how about t? To 3, where t is bigger than 1. That's a bounded region. And so here's the interval from t to 3. And when I'm done evaluating, I'll take the limit as t approaches 1, at least on the right-hand side. So life's a piece of cake. Within the limit, I can deal with that integral. Does that give me a 2 root x minus 1 evaluated from t to 3? But that gives me a limit, which apparently I can't smell. Is that going to be a 2 root 2 minus a 2 root t minus 1? Now when I evaluate the limit, that second term completely goes to 0, and I'm merely left with a 2 root 2. So it is true that the value I came with first time around really is the area underneath this curve from 1 to 3, and albeit it's an unbounded region, but it has finite area. In other words, I can go to Home Depot and buy enough paint to paint that unbounded region's area. I will just not live long enough to actually get the job done because the region's unbounded. Now, when I take the limit of such an improper integral and I get a finite fixed real number, I sometimes say that improper integral converges, and in particular, it converges to that finite fixed real number. But again, I can refer to that number right there as the area underneath the curve here, as x ranges from here to here.